There are places on Earth where the ground itself remembers violence. The Dead Sea rests in silence now. Its waters hold more salt than life can bear. Its shores are white with minerals that time has left behind. But beneath this quietness lies something ancient, something restless. This is the lowest place on the surface of the Earth, a wound in the planet's skin, a valley carved not by rivers alone, but by forces moving deep below. Geologists call it a transform fault, a place where two great slabs of the Earth's crust slide past one another, grinding, fracturing, releasing energy that has been building for millennia. The African plate, the Arabian plate, they have been pulling apart for millions of years, creating this deep scar we now call the Jordan Valley. And in one corner of this valley, there once stood two cities. Their names have echoed through history, through scripture, through the moral imagination of countless generations. Sodom and Gomorrah, were they real? Did they burn as the old texts say they did? For centuries, these questions belonged to faith alone. But now, science has begun to offer answers. Answers written in ash, in shattered pottery, in layers of earth that still bear the scars of an unimaginable heat. This is a story shaped by time and patience. If you choose to remain with us, the Earth is about to reveal one of its most haunting transformations. The Bible describes it simply, devastatingly. Then the Lord rained down burning sulfur on Sodom and Gomorrah from the Lord out of the heavens, fire from the sky, cities consumed. A woman turned to salt for looking back. For thousands of years, this was understood as divine judgment, a moral lesson carved into the landscape. But what if it was also something else? What if it was geology? What if the earth itself spoke that day, in a language older than scripture? The Jordan Rift Valley is not a peaceful place. It never has been. It is a seam in the earth's surface where pressure accumulates, where energy waits, where the planet breathes fire when the tension becomes too great to contain. This valley sits atop what geologists call the Dead Sea Transform, a massive fracture zone stretching over 1,000 kilometers, from the Red Sea in the south to the mountains of Turkey in the north. It is one of the most seismically active regions on Earth. Earthquakes here are not rare events. They are rhythms, patterns written into the land itself. And where there are earthquakes of sufficient magnitude, there can be other phenomena. Fissures opening in the ground, gases rising from deep below, sulfur, methane, bitumen seeping to the surface, flammable, volatile, waiting for a spark. The ancients knew this land was dangerous. They built their cities here anyway, drawn by water, by trade routes, by the fertility that existed despite the harshness. The Jordan River flowed. The plains around the Dead Sea were green once, fed by springs that have long since vanished. Sodom and Gomorrah were not myths. They were settlements, places where people lived, worked, raised families, worshipped their gods. Archaeological evidence suggests they thrived during the early Bronze Age, roughly 4,000 years ago. They were part of a network of cities that dotted this valley, each one vulnerable to the forces brewing beneath their foundations. And then, one day, the earth moved. Not gently, not gradually, but with a violence that would be remembered for millennia. A violence so complete, so absolute, that it would be written into the foundational texts of 3 major religions. What happened that day? What force could turn thriving cities into ash and memory? The valley remembers, and the stones are ready to speak. To understand what was lost, we must first understand what once stood. The Dead Sea region 4,000 years ago looked nothing like the barren landscape we see today. Spring rains filled the wadis with rushing water. Gardens grew in the shelter of the valley walls. Date palms swayed in the breeze, Life was possible here, even abundant, if you knew where to find it. Sodom and Gomorrah were trading cities, crossroads between the civilizations of Mesopotamia to the east and Egypt to the west. Caravans passed through carrying spices, textiles, copper from the mines of the Arabic. The cities collected tolls, they prospered, but they also lived on borrowed time. The Jordan Rift Valley is what geologists call a pull-apart basin. As the African and Arabian plates move in opposite directions, the land between them subsides, sinks, fragments. The Dead Sea itself sits in one of these collapsed sections, more than 400 meters below sea level, the lowest exposed point on Earth. This geological instability creates what scientists call a seismically active zone. The ground here does not rest. It shifts, adjusts, releases pressure in sudden, violent bursts. Historical records from the region document major earthquakes every few centuries, some strong enough to topple cities, strong enough to alter the course of rivers, strong enough to split the ground open. And when the ground splits in this particular valley, other forces emerge. Beneath the Dead Sea lie massive deposits of salt, gypsum, and organic material compressed over millions of years. Deeper still, pockets of natural gas, sulfur compounds, bitumen, a thick, flammable tar that the ancients called pitch. The Bible itself mentions the valley of Siddim as being full of tar pits. These substances are not inert. Under pressure, they migrate upward through cracks in the rock. They seep to the surface. They accumulate. The people of Sodom and Gomorrah would have known about these seepages. They may have even used the bitumen for waterproofing, for construction, for fuel. What they could not have known was how dangerous this combination could become.
Before we continue this story, subscribe to the channel. Your support helps us tell the true stories of Earth's most powerful volcanoes.
A strong earthquake, fissures opening, gas escaping under pressure, bitumen igniting from friction, from lightning, from any number of natural sparks. And then, in an instant, the valley becomes an inferno. This is not speculation. This is geology. In recent decades, archaeologists working in the southern Dead Sea region have made remarkable discoveries. At a site called Tal El Hammam, east of the Jordan River, they uncovered the remains of a substantial Bronze Age city. Massive fortification walls, gates, public buildings, evidence of a thriving urban center. And then, in the destruction layer, they found something extraordinary. Pottery shattered into fragments no larger than a fingernail. Mud bricks melted into glass. Zircon crystals that could only have formed at temperatures exceeding 2000 degrees Celsius. Higher than any normal fire, higher than any pottery kiln. Temperatures consistent with an airburst or a massive thermal event. The destruction layer also contained spherules, tiny melted droplets of material blasted into the air and cooled as they fell. The kind of spherules you find at impact sites, or in places where extreme heat was released suddenly and catastrophically. Carbon dating places this destruction event at approximately 1650 BCE, right in the middle of the Middle Bronze Age, right when the biblical timeline suggests these cities fell. The evidence does not prove divine intervention, but it does prove destruction. Absolute, total, instantaneous. Something happened here that was powerful enough to generate temperatures capable of melting rock. Something that scattered debris across a wide area. Something that left the land uninhabitable for centuries afterward. The scientists who studied this site proposed a theory. An asteroid or comet airburst, similar to the Tunguska event in Siberia in 1908. An explosion in the atmosphere that released energy equivalent to a nuclear weapon. But there is another possibility. One rooted not in the sky, but in the earth itself. What if the earthquake that opened the fissures also triggered something deeper? What if pressurized gases, sulfur compounds, and flammable materials erupted from below with such force that they ignited in a massive explosion? What if the valley, for a brief and terrible moment, became a natural blast furnace? The geological conditions were all present. The seismic trigger was inevitable. The fuel was waiting beneath the surface. All it needed was the right moment, and on one morning, nearly 4,000 years ago, that moment arrived. There are moments in history when the planet asserts itself, when the forces we live upon, the forces we forget, remind us that we are guests here, temporary, fragile. For the people of Sodom and Gomorrah, that moment came without warning. The morning likely began like any other. Merchants preparing their goods, children playing in the narrow streets, smoke rising from cooking fires, the ordinary rhythms of Bronze Age life in a prosperous trading city. But beneath their feet, pressure had been building for years, decades, perhaps centuries. The Dead Sea Transform is a strike-slip fault, similar in mechanics to the San Andreas Fault in California. Two massive plates grinding past each other, not smoothly, but in fits and starts. Most of the time, they are locked together by friction. Stress accumulates, energy builds, and then, suddenly, catastrophically, they slip. The earthquake that struck the valley that morning was likely magnitude 7 or higher. Strong enough to be felt across the entire region, strong enough to collapse buildings, strong enough to open fissures in the ground itself. And when the ground split open, the valley released what it had been holding for millennia. Natural gas under pressure erupted from newly formed cracks. Hydrogen sulfide, methane, carbon dioxide, all escaping in violent jets. The air would have filled with the smell of sulfur. The ground would have hissed and groaned. People would have run, confused, terrified, not understanding what was happening. Then came the bitumen. The tar pits mentioned in Genesis were not metaphorical. They were real geological features. Thick, sticky deposits of petroleum that had seeped to the surface over thousands of years. When the earthquake fractured the subsurface rock, pressurized bitumen was forced upward through the new openings. It erupted in fountains. It sprayed into the air. It coated everything it touched. And bitumen, at the right temperature, ignites. Whether the spark came from a cooking fire, from lightning, from the friction of the earthquake itself, we cannot know. But once ignition occurred, the reaction was instantaneous and overwhelming. The gases exploded. The bitumen became fuel. The air itself seemed to catch fire. Temperatures soared to levels no human construction could withstand. Mud brick walls softened and collapsed. Wooden beams vaporized. Pottery cracked and melted. People ran. But there was nowhere to go. The valley became a furnace. The heat was so intense that it created its own wind, sucking air inward, feeding the flames, creating a firestorm that consumed everything organic. This was not a volcanic eruption in the traditional sense. There was no mountain, no lava flow, no ash plume rising into the stratosphere. But it was, in every meaningful way, a volcanic event. The Earth's interior releasing energy, materials, and heat to the surface in a sudden, violent burst. Geologists call this phenomenon a mud volcano or a gas eruption event. They occur in regions with active faults, organic-rich sediments, and pressurized hydrocarbons. The Dead Sea region has all three in abundance. In modern times, similar events have been documented in places like Azerbaijan, where natural gas eruptions create towers of flame hundreds of meters high. In 2001, an underwater mud volcano in the Caspian Sea erupted with flames visible for kilometers. These are not rare phenomena. They are expressions of Earth's chemistry, its pressure systems, its restless geology. The difference is that in the Bronze Age, there was no scientific framework to explain them. No seismographs, no gas detectors, no understanding of plate tectonics or hydrocarbon geology. There was only experience, raw, terrifying, absolute, and that experience had to be explained somehow. It had to be given meaning. It had to be placed within the cosmology of the time. So it became a story about sin and punishment, about divine fire raining from heaven, about cities so wicked that God himself destroyed them. But the story also preserved details. Sulfur, fire, smoke rising like a furnace. The destruction of the plain. The need to flee immediately without looking back. These are not abstract metaphors. They are eyewitness descriptions of a geological catastrophe, passed down through oral tradition, eventually written into the texts that would shape Western civilization. The story of Sodom and Gomorrah is both things at once. It is theology, and it is geology, sacred text and scientific record. The earth spoke that day, and humanity has been trying to understand its language ever since. When the fires finally burned out, nothing remained but ash and rubble. The cities were gone. The survivors, if there were any, fled north toward safer ground. The valley, scorched and poisoned, was abandoned. For centuries afterward, no one rebuilt their land was considered cursed, dead, and in a sense, it was. The soil was contaminated with sulfur compounds. The water sources were destroyed. The infrastructure was obliterated. The Dead Sea itself may have risen, flooding the southern basin where the cities once stood. Over time, salt and sediment buried what little remained. The cities vanished. But the memory did not. And now, 4,000 years later, we are beginning to uncover what the earth remembers. Science does not move quickly. It accumulates, layer by layer, year by year. Evidence gathered from soil and stone, examined under microscopes, dated with precision, cross-referenced against other findings. But sometimes, that slow work reveals something stunning. In 2005, archaeologist Stephen Collins began excavating at Tall El Hammam, a sprawling tell in the Jordan Valley. A tell is a mound formed by centuries of human habitation, each generation building upon the ruins of the last. From a distance, it looks like a natural hill. Up close, it reveals itself as compressed history. Tall El Hammam was enormous, larger than any other Bronze Age site in the region. Its fortification walls were massive, up to 5 meters thick in places. This was not a minor settlement. This was a major urban center. The dominant city of the southern Jordan Valley during the Middle Bronze Age. And then, abruptly, it was destroyed. The destruction layer was unlike anything Collins and his team had seen before. Normally, when a city is conquered or burned, you find evidence of warfare. Arrowheads, weapons, bodies buried in haste. Damage concentrated at gates and walls, where attackers would have focused their assault. But Tall El Hammam showed none of that. Instead, the destruction was total and indiscriminate. Every structure damaged, every wall collapsed. Debris scattered uniformly across the entire site, and the temperatures involved were staggering. Pottery does not normally melt. Even in the hottest kill fires used by ancient potters, clay reaches temperatures around 1000 degrees Celsius. It hardens, it may crack, but it does not liquefy. At Tall El Hammam, pottery had melted, not just softened or deformed, but actually liquefied, running like water before cooling into glassy puddles. Analysis showed exposure temperatures exceeding 2000 degrees Celsius. Mud bricks, the primary building material of Bronze Age architecture, had also melted. Their outer surfaces had vitrified, turning into a substance resembling glass. This kind of transformation requires not just heat, but sudden, intense heat, a thermal shock. Even more remarkable were the minerals. Zircon crystals recovered from the destruction layer showed evidence of shock metamorphism. The crystal structure had been altered at the atomic level by extreme temperatures and pressures. This is the kind of damage you see in meteorite impacts or nuclear explosions. Something had struck this city with the force of a bomb. The team also found spherules, tiny droplets of melted material, flash-heated to liquid, ejected into the air, and cooled as they fell back to Earth. Some were composed of melted pottery. Others were melted building materials. Still others were melted sand, transformed into tiny glass beads. Carbon analysis of the destruction layer showed another curious detail. The organic material, the wood and grain and textiles that would normally survive as charcoal in a fire, had been vaporized, completely consumed. Almost nothing remained. This was not the signature of a normal urban fire, not even a catastrophic one. This was something else entirely. The initial hypothesis was an airburst, an asteroid or comet fragment exploding in the atmosphere above the city, releasing energy equivalent to a thermonuclear weapon without the radioactive fallout. The Tunguska event of 1908 had produced similar effects, flattening forests across 2,000 square kilometers of Siberian wilderness. But there were problems with the airburst theory. The distribution of damage at Tall El Hammam was wrong. An airburst would have created a radial pattern, with destruction radiating outward from a central point. Instead, the damage was uniform, as if the entire city had been engulfed simultaneously. And then there was the sulfur. Chemical analysis of the destruction layer revealed elevated levels of sulfur compounds, not just trace amounts, significant concentrations, consistent with exposure to volcanic gases or hydrothermal fluids. This was the clue that shifted the interpretation. What if the destruction had come not from above, but from below? What if the earthquake that leveled the walls had also triggered a massive release of pressurized gases and hydrocarbons from the subsurface? What if those materials had ignited, creating a ground-level explosion hot enough to melt stone? The Dead Sea region is rich in natural gas, bitumen, and sulfur deposits. The geological conditions for such an eruption are present. Historical texts, including the Bible, reference tar pits and sulfur in this exact location. Eyewitness accounts describe fire, smoke, and the smell of burning. It all fits. Not as divine intervention, not as extraterrestrial impact, but as a natural geological catastrophe. Rare, devastating, but entirely within the realm of Earth's normal behavior in a seismically active rift zone. The Earth has done this before, and it will do it again. At Tall El Hammam, the destruction was so complete that the site was abandoned. For more than 600 years, no one rebuilt there. The Jordan Valley's premier city became a ghost town, a ruin, a warning carved into the landscape. Other settlements in the region also show signs of sudden abandonment during the same period. Bob, Ithra, Numera, Fifa, all of them along the Dead Sea's eastern shore. All of them destroyed within a relatively short time span. It is possible they all fell to the same event. A Hegyornau catastrophe. An earthquake powerful enough to fracture the valley floor from north to south, releasing gas and fire at multiple points simultaneously. Or perhaps it was a series of related events, aftershocks triggering additional eruptions. A cascade of destruction spreading across the valley over days or weeks. We may never know the exact sequence, but we know the result. An entire network of cities erased, a population displaced, a region rendered uninhabitable for generations, and a story that would be told and retold and written down and carried forward through millennia. A story that would shape how humanity understands punishment, survival, and the awesome power of forces beyond our control. The evidence in the ash tells us what happened. The texts tell us what it meant. Both are true. In their own way, Scripture is not a geology textbook. It was never meant to be. Its purpose is theological, moral, instructive. It speaks in the language of faith, not the language of plate tectonics. And yet, sometimes, the two languages converge. The account in Genesis is brief, only a few verses, but within those verses are details that align remarkably well with what we now understand about geological catastrophes in the Dead Sea region. The text speaks of sulfur and fire raining down from the heavens. In the ancient world, volcanic gases and burning bitumen erupting from the ground would have appeared to come from above. The sky would have darkened with smoke. Flaming debris would have been hurled upward and fallen back down. To an observer with no framework for understanding subsurface eruptions, it would indeed seem as though fire was falling from heaven itself. The text describes smoke rising from the land like smoke from a furnace. This is not poetic exaggeration. This is exactly what happens when large quantities of organic material burn at high temperatures in an oxygen-rich environment. The smoke column from a major fire can rise thousands of meters into the atmosphere, visible from enormous distances. The text emphasizes the totality of the destruction. Everything in the cities was destroyed. All the vegetation of the plain was consumed. This matches the archaeological evidence. Complete obliteration. No survivors found in the ruins. No attempt at rebuilding in the immediate aftermath. And then there is the detail about Lot's wife. She looked back, and she became a pillar of salt. For centuries, this was understood purely as allegory. A lesson about obedience, about not dwelling on the past, about the cost of hesitation, and perhaps it is all those things. But it may also preserve a geological observation. The Dead Sea region is famous for its salt formations. Pillars of salt rise from the landscape, sculpted by wind and water erosion. Some of them are vaguely humanoid in shape. Even today, tour guides point out formations called Lot's wife. But there is another possibility, darker and more literal. If someone fleeing the destruction paused on high ground to look back, they would have been exposed to the gases and heat still pouring from the valley. Hydrogen sulfide, sulfur dioxide, superheated air. Exposure could have been fatal. And if the body was later found, encrusted with salt from the mineral-rich environment, it would have appeared petrified, transformed. The text may be recording what someone actually saw. A victim of the catastrophe, preserved by the chemistry of the land itself. We cannot prove this. But we can recognize that the description is consistent with known geological phenomena. The Bible also places the destruction in the context of a larger moral narrative. The cities were judged for their wickedness. This framing gave meaning to an otherwise incomprehensible disaster. It provided an explanation that fit within the religious worldview of the time. But meaning and mechanism are not mutually exclusive. A geological event can have theological significance. The Earth's violence can be interpreted as divine action without negating the physical processes involved. This is not a new idea. Throughout history, natural disasters have been understood as both natural and supernatural. Earthquakes, floods, plagues, all have been seen as expressions of divine will operating through natural means. What has changed is our ability to understand the mechanisms. We can now trace the fault lines, measure the gas emissions, date the destruction layers, map the thermal signatures. We know how the Earth does what it does. But that knowledge does not diminish the power of the story. If anything, it deepens it. Because the story of Sodom and Gomorrah is not ultimately about geology. It is about vulnerability, about living on a planet that is alive in ways we barely comprehend, about the fragility of human settlements built on unstable ground. It is about the survivors, the ones who fled, the ones who had to rebuild their lives in a world that had been irrevocably altered. Stories like this are not meant to be rushed. They are meant to be followed by those who still listen. If this journey resonates with you, you are already part of fury of the earth. The destruction of Sodom and Gomorrah was not the last geological catastrophe in the Jordan Valley. The region continues to be seismically active. Earthquakes strike regularly, some strong enough to cause significant damage. In 749 CE, a major earthquake destroyed cities across the Levant. In 1033, another powerful quake caused widespread devastation. In 1927, a magnitude 6.2 earthquake killed hundreds and damaged structures throughout Palestine and Transjordan. The Dead Sea transform is still active. The plates are still moving. Pressure is still building. Another major seismic event is not a question of if, but when. Modern cities now occupy the same valley where Sodom and Gomorrah once stood. Jericho, one of the oldest continuously inhabited cities in the world, sits directly on the fault line. Ammon, the capital of Jordan, lies within the seismically active zone. Millions of people live and work in areas that could experience catastrophic shaking. We have better warning systems now. Seismographs detect tremors. Building codes require earthquake-resistant construction. Emergency response plans are in place. But the fundamental reality has not changed. We are still building our cities on a restless planet. We are still subject to forces far greater than ourselves. The text understood this, even if it framed it differently. Sodom and Gomorrah were destroyed not because they were uniquely wicked, but because they were uniquely exposed. They were in the wrong place when the earth decided to move. That is the deeper truth preserved in the story. Not moral judgment, but geological inevitability. And it is a truth we would do well to remember. To understand why this valley is so dangerous, we must step back, far back, to a time before cities, before humans, before the valley itself existed. 200 million years ago, the continents we know today were joined in a single supercontinent called Pangaea. Africa, South America, North America, Europe, Asia, all locked together in one massive landmass surrounded by a global ocean. But the earth beneath was not still. Deep in the mantle, convection currents moved molten rock in slow, inexorable cycles. Hot material rose, cooler material sank, and the thin crust floating above responded to these movements. Pangaea began to fracture. Slowly, at first, cracks appeared, widened, filled with water. The Atlantic Ocean was born. Africa and South America drifted apart, millimeter by millimeter, year after year, across millions of years. But the separation was not uniform. The African plate did not simply move as one piece. It began to split internally. A rift formed, running north to south through the eastern part of the continent. The East African Rift, a wound in the Earth's surface that is still widening today. This rift is where the African plate is tearing itself in two. In 10 million years, perhaps less, Eastern Africa will be a separate landmass. A new ocean will fill the gap. The continent will be forever changed. The Dead Sea transform is part of this same system. It is the northern extension of the East African Rift, the boundary where the African plate meets the Arabian plate. Here, the plates do not pull directly apart. Instead, they slide past each other, moving in opposite directions along a massive fault zone. This type of boundary is called a transform fault. The most famous example is the San Andreas Fault in California, where the Pacific Plate grinds past the North American Plate, causing the earthquakes that periodically devastate Los Angeles and San Francisco. The Dead Sea Transform operates on the same principles. The Arabian Plate is moving northward relative to the African Plate at a rate of approximately 5 millimeters per year. It does not sound like much, but over geological time, it adds up. Over the past 20 million years, the plates have moved more than 100 kilometers relative to each other, and every centimeter of that movement has been accompanied by stress, friction, energy accumulation. Most of the time, the plates are locked together. The friction between them is too great for smooth motion, so they stick. Strain builds in the rocks on either side of the fault. The crust bends, deforms, stores elastic energy like a spring being compressed, and then, suddenly, the friction is overcome. The plates lurch forward. The stored energy is released in seconds. The ground shakes violently, buildings collapse, fissures open. This is an earthquake. The Dead Sea Transform has produced some of the most destructive earthquakes in recorded history. In 31 BCE, an earthquake destroyed cities throughout Judea and killed tens of thousands. Josephus, the Roman Jewish historian, wrote that it was among the worst disasters ever to strike the region. In 363 CE, another massive earthquake devastated the eastern Mediterranean. Petra, the great Nabatean city carved into sandstone cliffs, was severely damaged. Cities along the coast were inundated by tsunamis. The death toll was catastrophic. In 749 CE, an earthquake estimated at magnitude 7.5 struck the region. Nearly every major city from Damascus to Jerusalem was damaged or destroyed. It marked the end of Byzantine prominence in the Levant and contributed to the consolidation of Islamic power in the region. These were not isolated events. They were expressions of the same geological process that destroyed Sodom and Gomorrah, the earth moving, adjusting, releasing pressure that had built up over decades or centuries, and each time the earth moves, there is the potential for secondary effects, landslides, liquefaction, flooding, and in regions with subsurface, hydrocarbons, gas eruptions. The Dead Sea Basin is particularly vulnerable to these secondary effects because of its unique geology. It sits in a deep depression, a polypart basin created by the motion of the Transform Fault. Sediments, thousands of meters thick, have accumulated here over millions of years. Ancient seas evaporated, leaving behind layers of salt and gypsum. Organic material was buried and compressed, forming petroleum deposits and natural gas. All of this material is under pressure, and when an earthquake fractures the cap rock that holds it in place, it can erupt. Modern surveys of the Dead Sea have revealed hundreds of pockmarks on the seafloor. These are craters formed by gas eruptions. Some are small, just a few meters across. Others are enormous, 50 meters or more in diameter. They are evidence that gas continues to escape from the subsurface, even today. Most of these eruptions are slow and relatively harmless. Gas bubbles rise through the water and dissipate into the atmosphere. But occasionally, when triggered by seismic activity, the release can be sudden and violent. In 2010, researchers documented a gas eruption near the Dead Sea shore that sent flames 30 meters into the air. It burned for several hours before exhausting its fuel supply. The event was not widely reported. It happened in a remote area. No one was injured, but it demonstrated that the potential for fire from the ground still exists. The same conditions that destroyed Bronze Age cities 4,000 years ago are still present. The Earth has not changed its fundamental nature. We have simply become better at monitoring it. Seismologists now track every tremor in the region. GPS networks measure the slow deformation of the crust. Gas sensors detect changes in subsurface pressure. Engineers design buildings to withstand shaking, but we cannot stop the plates from moving. We cannot prevent earthquakes. We cannot eliminate the risk entirely. All we can do is prepare. Understand, the Jordan Rift Valley is a reminder that we live on a dynamic planet. A planet that is constantly reshaping itself. A planet that does not pause for human convenience. The rift divides continents, and in doing so, it has shaped civilizations, determined the course of history, and left stories written in ash and memory. Stories that the earth continues to tell, if we are willing to listen. There is a common misconception that volcanoes must be mountains. Tall cones of rock that brood on the horizon, occasionally erupting with lava and ash. Vesuvius, Fuji, these are the images that come to mind when we think of volcanic activity. But the Earth's fire takes many forms. Not all eruptions come from traditional volcanoes. Some come from fissures. Long cracks in the ground that open suddenly, releasing lava across vast areas. The Loki eruption in Iceland in 1783 was a fissure eruption. It produced more lava than any Icelandic eruption in recorded history, covering nearly 600 square kilometers and killing a quarter of the island's population through famine and toxic gases. Other eruptions are even less obvious. They involve no lava at all, only gas, mud, superheated water. These are called phreatic or hydrothermal eruptions. They occur when groundwater comes into contact with hot rock or magma, flashes to steam, and explodes upward through the surface. Yellowstone National Park is famous for this type of activity. Geysers erupt on predictable schedules, sending boiling water hundreds of feet into the air. Hot springs shimmer with colors created by thermophilic bacteria. Mud pots bubble and hiss, releasing gases from deep below. These are volcanic phenomena. Even though there is no visible volcano, even though no lava flows, the Earth is releasing energy and material from its interior. That is volcanism. And then there are the gas eruptions, the kinds that can happen in sedimentary basins, where organic material has been compressed over millions of years into petroleum, natural gas, and related compounds. Azerbaijan, on the western shore of the Caspian Sea, is home to dozens of mud volcanoes. These are not mountains of rock, but mounds of mud and clay pushed up by pressurized gas from below. Periodically, they erupt. Gas jets ignite and burn for days or weeks. Some eruptions are large enough to be seen from space. In 2001, a submarine mud volcano in the Caspian Sea erupted with flames reaching 15 meters above the water surface. The fire burned for hours, visible from the coast. Sailors reported seeing the sea itself appear to be on fire, as gas bubbles rising through the water ignited on contact with air. These eruptions are dangerous. In 1902, a mud volcano near Baku exploded with such force that it created a crater 60 meters deep and killed several people who were working nearby. The gas cloud that accompanied the explosion was toxic, suffocating anyone who could not escape quickly enough. The Dead Sea region has all the geological ingredients for similar eruptions. Thick sedimentary layers, organic-rich deposits, natural gas under pressure, active faulting that can create pathways for rapid gas release. And it has a documented history of such events. Ancient writers, including the Roman historian Tacitus and the Jewish historian Josephus, described the Dead Sea as a place where bitumen rose from the depths. They wrote of blocks of tar floating on the surface, large enough to be harvested and sold. This bitumen was valuable. It was used for waterproofing boats, preserving mummies in Egypt, and as an ingredient in medicines. But the appearance of bitumen on the surface was also a sign. It meant that material from deep underground was finding its way up. That pressure was escaping. that the subsurface was active. Greek writers referred to the Dead Sea as Lake Asphalt Lake. Pliny the Elder wrote that the lake produced bitumen at irregular intervals, preceded by earthquakes and accompanied by foul odors. These descriptions match what we would expect from periodic gas and petroleum seeps triggered by seismic activity. Small eruptions, releasing material gradually. But if the conditions were right, if a major earthquake fractured the cap rock across a wide area, the release could be sudden and catastrophic. Imagine the ground opening along multiple fissures simultaneously, gas under high pressure jetting upward, bitumen spraying into the air, the gas cloud spreading across the valley floor, heavier than air, displacing oxygen, suffocating anything that breathes, and then ignition, from lightning, from fire already burning in the city, from the friction of rock grinding against rock in the earthquake itself. The gas would explode, not all at once, but in a cascading series of blasts as each new fissure ignited. The bitumen would burn with intense heat, far hotter than wood or oil, temperatures high enough to melt pottery, to vitrify brick, to vaporize organic material. This is not speculation. This is chemistry. This is physics. This is what happens when pressurized hydrocarbons meet oxygen and an ignition source. And it has happened before. Not just at Sodom and Gomorrah, but in other places, at other times. We simply do not always recognize it for what it is. In 1908, a massive explosion occurred over the Tunguska region of Siberia. Trees were flattened across 2,000 square kilometers. The blast was heard hundreds of kilometers away. For years, the leading theory was an asteroid or comet airburst. But some researchers have proposed an alternative. The region sits above gas fields. Could seismic activity have triggered a massive gas eruption that then ignited? The evidence is debated. The mystery remains unsolved. In 1986, Lake Nyos in Cameroon released a cloud of carbon dioxide that had been accumulating in its depths. The gas, heavier than air, flowed down the surrounding valleys, suffocating over 1,700 people as they slept. It was a limnic eruption, a sudden degassing event triggered by unknown causes, possibly a landslide or small earthquake. The lake is now monitored. Pipes have been installed to slowly release the gas before it can accumulate to dangerous levels again. But the event was a reminder that the earth can kill without violence, without fire, without obvious warning. Just a silent release of gas. And then death. The Dead Sea could produce a similar event. The water is saturated with minerals. Gas could be accumulating in pockets beneath the lake bed. A strong earthquake could trigger a release. We do not know the probability. We cannot predict the timing. But we know the potential exists. The earth breathes. Sometimes gently. Sometimes with devastating force. And we, living on its surface, must remain aware that the ground beneath us is not as solid as it appears. It is thin crust floating on a molten interior. It is fractured rock under immense pressure. It is chemistry waiting for the right trigger. The mountains breathe fire, even when they are not mountains. Even when the fire comes from below, there is a silence in the Dead Sea region that feels older than history, a stillness that is not peaceful, but watchful. The land has seen empires rise and fall. It has swallowed cities. It has shaped the stories that billions of people hold sacred. And it remembers. Walk along the shores of the Dead Sea today, and you will see the evidence of its restlessness. Sinkholes appear with alarming frequency, some large enough to swallow cars or buildings. They form when underground salt deposits dissolve, creating voids that suddenly collapse. The ground simply opens. Without warning, more than 7,000 sinkholes have formed around the Dead Sea in the past 3 decades. The rate is accelerating, Areas that were stable for centuries are now too dangerous to approach. Roads have been abandoned. Tourist facilities have been evacuated. The land is quite literally falling apart. This is happening because the Dead Sea itself is disappearing. Water levels have dropped more than 30 meters since the 1960s. The Jordan River, which once fed the lake with substantial freshwater flow, has been diverted for agriculture and drinking water. What remains is a shrinking body of water, increasingly sickening, leaving behind a landscape of exposed salt flats and unstable ground. As the water recedes, fresh water from underground aquifers flows into the newly exposed areas, dissolving the salt layers beneath the surface. The result is a honeycombed subsurface, riddled with cavities that will eventually collapse. This is a human-caused disaster. But it is also a reminder of the region's inherent instability. The Dead Sea Basin has always been a place of subsidence, of collapse, of material being pulled downward by gravity and tectonic forces. 4,000 years ago, the cities of the plain were built on ground that was already unstable. They did not know it. They could not have known it, but they were living on borrowed time, in borrowed space, above cavities filled with pressurized gas and volatile materials. Modern technology allows us to see what they could not. Ground-penetrating radar reveals the subsurface structure. Seismographs record every tremor. Satellite measurements track the slow deformation of the crust with millimeter precision. We know that the Dead Sea transform is locked. Stress is building. The last major earthquake on the southern segment of the fault occurred in 1927, nearly a century ago. Statistically, the region is overdue for another significant seismic event. When it comes, it will not be a surprise to scientists, but it may be devastating nonetheless. Millions of people live in the potential impact zone. Infrastructure, much of it built before modern earthquake codes were implemented, is vulnerable. Water systems, power grids, communication networks, all could be severely damaged. And if the earthquake is strong enough, if it opens new fissures in the subsurface, there is the possibility of gas eruptions similar to those that may have destroyed Sodom and Gomorrah. We cannot prevent this. We can only prepare for it. But preparation requires acknowledging the risk. And acknowledging the risk requires confronting uncomfortable truths about where we choose to build and why. The Jordan Valley is strategically important. It is fertile, it has water, a precious resource in an arid region. It has been a corridor for trade and migration for millennia. Cities have always been built here, despite the dangers, because the benefits outweighed the perceived risks. That calculation has not changed. People continue to live and build in seismically active zones all over the world. Tokyo, Los Angeles, Istanbul, Tehran, each of these cities faces the possibility of catastrophic earthquakes. Yet they thrive, they grow, they endure, because humans are optimists. We believe the disaster will not happen in our lifetime. We trust that modern engineering can protect us. We adapt rather than retreat. And often, we are right. Modern buildings can withstand shaking that would have leveled ancient structures. Early warning systems provide seconds or minutes of notice, enough to take cover. Emergency response has improved dramatically. But no amount of technology can eliminate the fundamental reality. The Earth moves. And when it does, we are reminded of how small we are, how temporary our constructions are, how quickly the veneer of civilization can be stripped away. The land remembers this, even when we forget. At Tal El Hammam, archaeologists continue to excavate. Each season reveals new details about the city that once thrived there. Storage jars filled with grain, jewelry, tools, evidence of daily life abruptly interrupted. In one building, they found a table still set with pottery bowls. In another, loom weights scattered on the floor where the weaver had been working when the destruction came. These are not abstract data points. These are human moments, frozen in time. The people of Sodom and Gomorrah were not wicked. They were not uniquely sinful. They were ordinary. They were farmers and merchants and artisans and parents. They woke up, they worked, they loved, they argued, they hoped, and then, in one terrible morning, their world ended. Not because they deserved it, but because they lived on a fault line. Because pressure had been building beneath their feet. Because the earth decided, in its slow and inevitable way, that it was time to release that pressure. This is the story the land tells. Not of divine judgment, but of geological inevitability. Not of sin and punishment, but of cause and effect operating on timescales we struggle to comprehend. The Dead Sea transform will move again. The ground will shake. Buildings will fall. Lives will be disrupted. And centuries from now, archaeologists may excavate our ruins and wonder what happened. They may find melted glass and twisted metal. They may find evidence of sudden abandonment, and they may tell stories about us, stories that try to make sense of disaster, stories that assign meaning to forces beyond human control. The land will remember, as it always has, and the cycle will continue, as it always does, on a planet that is alive in ways we are only beginning to understand. There is a reason the story of Sodom and Gomorrah has endured for 4,000 years. It is not because it is unique. Most are forgotten, their names lost, their ruins buried beneath time and sand. But Sodom and Gomorrah were different. They were witnessed, they were remembered, they were written down. The story served a purpose for the people who told it. It explained the inexplicable. It gave meaning to suffering. It reinforced moral codes and community boundaries. It reminded listeners that certain forces, whether divine or natural, are beyond human control. We still need stories like this. Even now, with all our scientific understanding, we need narratives that help us process catastrophe, that remind us we are not invincible, that teach us humility in the face of powers vastly greater than ourselves. The difference is that now we have two ways of reading the same story. We have the theological interpretation, which speaks to questions of meaning, morality, and the relationship between humanity and the divine. And we have the geological interpretation, which speaks to questions of mechanism, probability, and the relationship between humanity and the planet we inhabit. Both are valid. Both are necessary. They are not in conflict. They are complementary perspectives on the same event. The earth destroyed Sodom and Gomorrah. That much is clear. Whether one chooses to see that destruction as an act of God operating through natural processes, or simply as geology expressing itself without intentionality, is a matter of worldview, of faith, of interpretation. What is not a matter of interpretation is the physical evidence, the melted pottery, the vitrified brick, the destruction layer that can be dated and analyzed and understood in chemical and physical terms. The earth spoke, violently, definitively, and the people who survived carried the memory forward. That is the true legacy of Sodom and Gomorrah. Not the destruction itself, but the remembering, the storytelling, the determination to ensure that what happened would not be forgotten. Because forgetting is dangerous. When we forget that the earth can move beneath us, we become complacent. We build in places we should avoid. We ignore warnings. We assume stability where none exists. The Dead Sea transform is still active. The Jordan Rift Valley is still pulling apart. Gas is still accumulating beneath the surface. Earthquakes are still inevitable. These are not ancient threats, they are present realities. And the cities that now occupy the valley, the millions of people who live there, are subject to the same geological forces that destroyed their Bronze Age predecessors. We have better tools now, better knowledge, better preparation, but we do not have immunity. We cannot opt out of living on a dynamic planet. All we can do is pay attention, listen to the land, respect what it tells us, and build our civilizations with the understanding that permanence is an illusion. Nothing lasts forever. Not cities, not empires, not even mountains. The earth reshapes itself constantly. It has been doing so for 4.5 billion years. It will continue long after we are gone. Our presence here is brief. A moment in geological time. A thin layer in the fossil record that future beings, if any exist, may one day excavate and wonder about. What will they make of us? What stories will they tell? Perhaps they will find our ruins and see evidence of sudden abandonment. Perhaps they will speculate about catastrophe. Perhaps they will create their own narratives to explain what they find. And perhaps, if they are wise, they will recognize what we are only now beginning to understand. That disaster is not punishment. It is not random. It is the earth being itself, operating according to principles of physics and chemistry that are older than life itself. The story of Sodom and Gomorrah is ultimately a story about perspective, about how we frame the events we experience, about the narratives we construct to make sense of a world that is often senseless, violent, and indifferent to human concerns. The Bible gave that story one frame. Science gives it another. Both frames are useful. Both contain truth. The planet will continue its ancient rhythm long after we are gone. The plates will keep moving. The faults will keep slipping. The gas will keep rising. Fire will erupt from the ground again, somewhere, sometime, when the conditions align. And when it does, survivors will tell stories. They will try to explain. They will search for meaning. They will remember, because that is what we do. We are the species that remembers, that tells stories, that tries to understand. And in that trying, in that remembering, we connect ourselves to everyone who came before. To the people who fled Sodom. To the witnesses who saw the smoke rising. To the scribes who wrote it down. To the generations who read it and wondered. We are all part of the same story. The story of living on a planet that is beautiful and terrible, nurturing and destructive, home and hazard. The earth remembers, in stone, in sediment, in the chemical signatures of ancient catastrophes. And we remember, too, in words, in texts, in the stories we carry forward and pass to those who come after. If you wish to keep walking beside these powerful forces, subscribe to Fury of the Earth, and join us in the next chapter of the planet's unfolding story. The valley is quiet now. The Dead Sea glimmers under the sun. The ruins of ancient cities sleep beneath the sand. But the earth is only resting. Never still, never truly silent. It is waiting, as it always has, as it always will. And we, on the surface, must learn to listen.